Greetings, the Astro 30 here, and welcome to a brand new video for you. The PCB that I've ordered for the Simple Home Audio Power Amplifier has arrived today. I probably won't get around to assembling it today because I've just finished work. I'm a bit tired, but it'll be assembled in this video, but I just take a few days to actually finish the video. However, let's unbox this and we'll have a look at what we've got. Be up to their usual standards. That's not the entrance, that's the entrance. There's a couple of other PCBs in here for other stuff which is not relevant to this project. This is the one we want. As I said, up to their usual standards, nicely bubble wrapped. Here we go. Bass Buddy. And my cute little anime girl, which I'm still waiting for someone to comment and say who that is and where it's from. Anyhow, we'll just carefully cut around the bubble wrap so I can extract one of these PCBs. Maybe, maybe not. Maybe go f*** yourself. That's exactly what this bubble wrap is saying to me. Go f*** yourself. Every time I receive a new PCB, it's like Christmas. However, I can still never get into the goddamn packaging. Oh, by the way, there's the board code for you. I will make this project available on PCBWay to order a PCB. However, I'm no longer allowing the Gerber files to be downloaded because people with that adjustable power supply was just downloading the Gerber and not ordering the PCB through PCBWay. So if you don't do that, I don't get a discount on my next PCB because that's worth points. So I'm treating it like a business. Anyway, one PCB extracted. And there it is in all its glory. And I thought I made a mistake on my silk screen and put slow blow here, or SB for the fuse. It's meant to be a fast blow, but no, I have marked it correctly. Looking at the underside, I've gone for as thick a trace as possible for the voltage rails and some of the output especially, and parts of the high voltage DC ground return. So yeah, there's that. It's absolutely beautiful, and that's going to look so great when it's assembled. I've got all the parts I need for it. Some are stored in a container, but I went out to Jayco and I've bought 10 of these 100 nanofarad 100 volt MKT capacitors because every time I go into the Kingston one, they never had any. Not lately anyway, so there was 10 in the box. I thought, well, yeah, I always use them, so I took all 10. I've got 4 3-amp fast blow fuses because that Elliott Sound Products amplifier at plus minus 42 volt requires a 3-amp, not a 5-amp fuse, so I have to change them anyway. I've got 2 new BD139 and 140 respectively because the ones I was using in the test jig in my breadboard were overheated in a previous experimentation, so I don't know if I've damaged the transistors, which may be a reason why the frequency response is a bit bad on it. But then again, the board also has a char mark in it. Right here where I destroyed an op-amp IC by plugging it in incorrectly, and some components were connected to the path where this is damaged, so there might be damage to the component clips, rails, whatever you want to call them, underneath, which may, because that was part of the biasing circuit as well, so it may have affected it. I don't really know. And finally, one HH85730, which is a 105 long heatsink by 135 deep by 35 high. So the idea of that is that this board will mount vertical to the heatsink in where the flat area is on the other side, because it's not finned all the way through. There's a nice flat mounting area there. So it'll mount like that, vertical to the heatsink, and the heatsink will be placed into the speaker box like that up against the back. So it'll be sort of like that. So anyway, without talking about it, we should probably start assembling this beast, test it out, and see if it works better than it did on the breadboard, which it should. Also, one more thing is I'm going to use a PCB pin here at the input rather than a connector, because, well, I don't think I've got any of these connectors anyway. Plus, I only need a single input here. You take the shielding of the audio cable off of the preamp's ground and then don't terminate it here, so it's cut off at this end, so you've only got the hot lead going through, and the shield will receive the ground up through it up to this point to prevent noise, so we're not causing any ground loops. And do you like my smart ass board code here? If anyone wants to work out what that actually says, it's rude, but I like putting rude things on PCB sometimes. It says A P3N15-23B. Alright, anyway, let's get this assembled and test it out. I've got most of the board assembled. I'm just missing 2 BC558 transistors that I forgot to buy today. So I'll get some tomorrow. I've also forgotten to get the sill washers that go on the TIP35 and 36C transistors, so I can't mount it to a heatsink yet. I know I did say I wasn't going to assemble it tonight. Well, I relaxed, I lied, and then I just assembled. So we've got that far. I'll just pop these 3 amp fuses in now. Oh, that was completely off kilter. Let's see if that one fits in there better. Yay! Okay, looks like I've assembled everything right so far. Those 5-watt resistors are really close to things, but it fits. Take note that the BD139 transistor, that's the VAS transistor, the metal face of the transistor where the heatsink normally mounts faces towards the front of the board so that the emitter is on the right, otherwise it'll be backwards in circuit and it won't work. Alright, so I've just got to get those transistors and then we can conclude assembly. It looks pretty snazzy, doesn't it? I had an issue with a couple of these spade terminals and that one's not very straight. I was soldering them in and they just fell straight back out. I'm going to have to take the solder off the edge of that one. That's a bit wanky. I can fix these up off camera, that's fine. Anyway, moving on. BC558s are installed and I've also got some angle brackets to mount to the heatsink. The output stage is almost ready to install. However, I need to drill the heatsink first in order to mount the transistors to the heatsink. And I may have an issue trying to get a screw into here into the heatsink with the PCB in the way. I might have to put the brackets on the heatsink first and then screw the PCB to it. Anyway, I've now got to mark out the holes on the heatsink ready to drill, and yeah, I'm going to do that now. Okay, so I've got the heatsink all marked out as to where I've got to drill. It looks discombobulated, but yeah, it is what it is. I haven't marked where the holes from the outside screwed to the cabinet are yet. I was mainly interested in where the power transistors, the driver transistors, and the mounting points were located. They're already countersunk, not countersunk, pre-punched, ready to drill. So all I've got to do now is just drill it. Penis. Alright, I'm now ready to drill the heatsink. Using a 2mm bit because my 2.5 broke when drilling another heatsink. So I'm going to just start somewhere. Alright, that took longer than necessary. I've got a bit of cardboard here to catch all the junk. It's going to be hard going, but you know, it's doable. Yep. Oh, that's hard on the arms and the drill. That's 6 of the 10 holes I need to drill. I've got to drill 4 holes either end of the heatsink yet. Alright, so I'm ready to tap the holes now, so I'm just going to take off my tape. I don't need it anymore. Okay, and I've got a M3 tap in here, and the way I do this is just slowly and try to get it as straight as possible. And I broke the tap. Bastard. Right, well that sucked. So it's what we do about it. I managed to get the broken tap out. So what I'm going to do is I'm just going to drill the holes out to 3.2mm and just use bolts and nuts. Still works the same. Would have been nice to have it tapped, but it didn't work that way. God damn. Okay, second phase is drilling the mounting holes to the cabinet, and I've already drilled the pilot holes. I'm going to size them out to 4mm, which should be enough to accept a wood screw to go through. Actually, 4 might be a bit big. I might change that to 3.5 actually, just to be on the safe side. I don't need it probably that big, so I'll just change them. I reckon, well, I can drill one and then try one of the wood screws that the cabinet comes with. Alright, here we go. Alright, this one will do. Okay, yeah, it is a bit tight in the hole, so I might go for the 4. That should be big enough, I think. Yeah, load's big enough. Alright, do the other 3. So, let's get rid of all this crap. Okay, so I'll now peel the tape off. Wonderful. The heatsink looks like it is drilled. Now I just need to deburr it and give it a bit of a clean. So whatever I did with my 6.5mm drill bit, it'd be nice to know where it is, because I've lost it now. You okay, it's disappeared. Oh. Right in front of me. I measured it 40 in from each edge here, and 10 in from the sides. The screws I'm going to use probably aren't as high of a profile, but the screws fit in there just nicely, so I reckon that should be fine. Alright, deburred. Now I need to give it a bit of a clean and clean up the desk a bit. Penis! Alright, I've got the PCB mounted and bolted to the heatsink. So I'm now just going to bring in my transistors, and I'm going to make sure I've got the right ones in the right holes. That's the 35. That goes over here on your right. So I'm going to use 15mm long bolts for this. I've just got to find the hole. There we go. I've already pre-bent the leads of this transistor by about 1mm. I'll show you on the other transistor in a second. I'm going to just lightly put that in there. So as you can see, the legs are bent forwards by 1mm. A little bit of a kink there, just to bring the back of the transistor more flat with the heatsink. Well, that's the idea anyway. And I don't even know why I'm putting the isolators in at the moment, because I've got to take this apart again anyway to solder it. So that's kind of preemptive, but oh well. So now I've just got to get this to go in the hole. Go in there. The leads are not exactly straight, which is causing a problem. Right, that one's in. Another 15mm long nut, and my isolator is not agreeing with me, and neither is the bolt. I mean, seriously? Story of my life, having trouble finding the hole. How far off am I? I'm right on it. So I tend to hate this fiddly shit. Not sure why that's not going in there. Because the transistor's too high. I think the leads are bent on that wrong. Yep, I had to slightly rebend the leads. Try not to overbend them so I'm not stressing them. Now what I'll do is just get this nut to start and I'll be happy. Alright, that went on the floor, I'll go find it in a minute. Okay, that just only needs to be tight enough just to hold it in place whilst I solder the centre lead at least. I think I'm going to have to bend them probably about 2mm out. Which one's that? That's the 140. That one goes in that place. So I'll just go right up to the top of the transistor body and then just give them a slight kink so that they fit a little more flush with the heatsink. Well, that's the idea anyway. I'm trying to work around a tripod, so it's kind of awkward. And before I finalise the soldering on these, I'll make sure that each transistor is in the right place, because there's nothing worse than soldering the transistor in the wrong place and then finding that it doesn't work. Because, well, you f***ed up. And I might actually change these 10mm long screws to 15s, because they're very short. The fact that hardly any of the head is sticking through, so yeah. Alright, so this is the same procedure. I'm just going to solder the centre pin. That one was a little bit easier to solder. That one missed totally. Now it's got it. Now, to pull it apart. Gravity. Alright. Yippee-ki-yay, mother. I'll touch up the centre leads in a minute. I just want to get this soldered in. Check it out, there we go, it is assembled. All the screws are tight. There's no issue with fitment or anything, like what I mean is transistors not mounting flush with the heatsink or anything. The drivers don't really need to be attached to the heatsink, but they are just for convenience. Now, we're ready for testing, but first we need to make sure that the heatsink is isolated from each of these devices. So that's the first test I'm going to do before powering it up, because there's nothing worse than it being shorted and blowing stuff up, including the transistors. And yes, I did actually change those two 10mm screws to 15. So to make this easier, I'll just connect one lead to a screw. Well, that one's not giving me a continuity on that screw. It's not a bad thing, but it doesn't help my testing procedure here. Okay, well, whatever. That transistor is isolated. Put it back there. Now I should have 1, 2, 3. Okay. Isolated. 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 Power supply is isolated from the heatsink as well. Double check that the power supply is not shorted. Well, that really worked, didn't it? Let's try that again. No problems. This is ready
to power up and test. But I'm going to have a coffee break first. Penis. Alright, I've got the toroidal transformer set up, my AEL 480 power supply. That's connected to here through two 100 ohm limiting resistors. I've got the big boys multimeter there in the background on voltage DC across one of these 100 ohms. And I'm going to measure the voltage drop first across this resistor. Now, the output stage should not be drawing any more than 30 to 60 mA. So I do not expect to see a voltage drop across this resistor any higher than 6 volts. If it is, or we're getting close to the rail voltage, which is 35 volt, there is a serious problem. So hopefully nothing goes up with a bang. I'm going to plug it in now and see what it does. Wish me luck. Here we go. Nice. Well, that's unexpected. That's a really low current draw. That's only 758 millivolts. So
ohms. It's not just fun, it's the law.
It says that current equals the voltage divided by the resistance. So we're looking at 0.755 currently divided by 100 ohms. That's about 7 milliamps, 8 milliamps, which is pretty good. So a quiescent current of around 7 milliamps is bonza. Right, next thing to test is the DC offset on the output, which is going to be a little bit more awkward to test. So first I'm going to unplug it so I can move some test leads around without accidentally shorting something and killing it. So I need to go from ground and the output. If it passes this test and we have very little DC offset, I'm going to hook it up to an oscilloscope. So I'll plug it in again. And well, we're looking at, I'm assuming that it's actually connected to the output. Well, apparently, yeah, it is changing. We've got around about 53 millivolt, which is not too bad. So having a DC offset of 50 millivolts, it is a little high, but I'm just going to touch the input of the amplifier. I can see right away that is actually working as an amplifier. It's passing the blurt test. Okay, so I need to hook up an oscilloscope, dummy load, and an oscillator, and we can test the output. And nothing's getting hot that I can feel. So, alright, let's do that. Alright, everything's set up, oscillator, oscilloscope, dummy load, and the power is connected directly to the power amplifier now. So I'll plug the concoction in, and we can see we do actually have an output voltage. Isn't that nice? So I'm going to increase the gain of the oscillator. Look at that. And we're clipping there. So I need to figure out where it clips at. Ooh. Around about the 60 volt mark. So I might just increase my, not that one, that one. There we go. So I can better see what I'm doing. At least the waveform's clean. Yeah, we're clipping at 60 volt and it is symmetrical. So what are we going to say? 60 volt peak to peak? Alright, 60 volt peak to peak it is. So that's a voltage of 30. I think I've done this calculation once before. So square it, divided by a load, 112 watts peak, 30 at RMS, because I don't trust the RMS reading on the oscilloscope. Multiply it by itself, because that, I'm saying 50 watts. 50 watts, closer to 60. Bonza, so that's 50 watt RMS, which would be about right for the topology of this circuit. So I'm happy. That's what I was aiming for, was 50 watts RMS. And yeah, the heatsink's starting to warm up. But no, that's great. And it worked first time, which is also great. So what I want to do now is I want to check the frequency response. So I'm going to set the waveform so the peaks either side, negative and positive, are touching the graticule up and down from the 0 volt line, so we can see if there's a change in power output. So first I'm going to have to change from down to the next one down 10 to 100 Hertz, so I can set my thing up. And I've got to change. Oh, that's too far. Now I have no idea what I'm on. Prozac probably. Anyway, that's 7 Hertz, which is probably as low as this thing can go. And the voltage hasn't changed that much. But anyway, I'll wind it up, frequency up, till we're coming into where I suspect the thing cuts off at, which is 20 Hertz. Currently we're at 14 and it's remaining the same voltage, which is good. So I'll increase that a bit more. Waveform's not perfectly symmetrical, but anyway, we're at 20 Hertz now. Wind them up. And so far, at 50 Hertz, we're looking pretty flat. Voltage is not deviating that much, which is always a good thing. And I've run out of wick on the oscillator, so I'm going to have to change the setting again. So we know it's fine up to 1 kilohertz. So I think I'm going the wrong way, as usual. Right, so there we are at 3 kilohertz roughly. So I'll wind him up. Voltage isn't deviating that much, it is remaining relatively flat. We're at 6 Hertz, kilohertz, 10 kilohertz. 12, 20 kilohertz, and it starts rolling off. So we're starting to roll off around about the 18 kilohertz mark. So this is not very accurate, I must admit. I'll just get a little bit closer. Yeah, it starts rolling off around about the 18 kilohertz mark. So that is not bad at all. That is perfectly acceptable. That's a good frequency response. I'm happy. One thing I forgot to do was do a input sensitivity test. So I need to find out before clipping what our input sensitivity is. So that's roughly where the voltage should be. So I'll just unplug the amplifier because I don't really need it plugged in for this test. So with the oscilloscope connected directly to the output of the oscillator, we're looking at 2.41 volt peak to peak going into it for input sensitivity for a full output of 50 watt, which is about right. Okay, well now I can pack up all the test equipment and we can do that all important sound test, and I can't even talk now. Alright, I've got everything set up, laptop, Focusrite interface, speakers, got to be careful that they don't short because there's no output short circuit protection, it'll blow the fuses. Got an input going in. Now I wonder if this is going to make any rude noises when I plug it in. Not really. Okay,
let's play a track. That's loud. That works excellently. It works better than it worked on the breadboard. I'm quite happy about that. No turn off transient. Wait for the filter caps to discharge. There it goes. Fast transistor is not hot. The generation resistors for the emitters is not hot. Everything seems to be working perfectly. I better stop the audio from playing on the laptop too. Right, so that little amplifier project worked out great. Works better on the PCB as I suspected. Why would it not? So yeah, I'm going to make this project available with a link in the description so you can order the PCBs. Anyway, I'm going to end this video here now, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon member for as little as $1 a month. The links are in the description as usual, guys. Anyway, this is the Astro 30 saying see ya. I am very, very happy. Yippee-ki-yay, mother...